basically, first I would ask that you guys go to this URL, like open a browser, go to this URL. This will take you to a master handout. The handout, it's on Google Docs. Let me bring it up really quick. No, that's not it. So basically, this URL here should bring you to, so basically tinyurl.com/comsoc17-savi. And that should show you a Google Doc that we prepared. So today, for the purposes of time, we'll just do a very simple SAVI basic. I basically prepared 3 things, 2 of which is for the morning and 1 is for the afternoon. For the purposes of time, we'll really skim through a really fast SAVI basic. So SAVI is a national-wide testbed. It's a cloud, as Professor Leon Garcia introduced earlier. Yesterday, the presenter yesterday, is he here? Oh, he left? So he talked about different types of cloud technologies, and he mentioned OpenStack a couple times. How many of you have heard of OpenStack or are familiar with OpenStack? 1? Okay. OpenStack is an open source software suite that allows you to create your own cloud. And SAVI is primarily built upon OpenStack, plus a few other components that we built in-house ourselves. So most of the SAVI basic stuff is based on OpenStack. For the SAVI basics part, the actual Google Doc handout contains way more stuff than you're actually going to do today. What I'll have you do right now is, in the next 15 to 20 minutes, simply just learn how to boot up a virtual machine of your own and SSH into that virtual machine, right? So this virtual machine will be on the actual SAVI testbed itself. And then on your own time, if you're interested, because you have the link to this handout, you could probably bookmark it if you want. You have the link, you have the credentials, you can probably go back and fiddle around a little bit more, play around with the other stuff in the handout.
Excuse me, can I have the link?
Oh, yeah. Yeah, usually when we do this, we have 2 monitors side by two screens side by side, where I have to hand out on one and then slides on the other. But so yeah, can you see? Did you get it? And if I'm going too fast, or if anyone has any questions, just do please interrupt me. Love me as much as possible. So yeah, how to access the SAVI testbed. Today, so there's 2 primary methods. We have a SAVI portal, which is a web UI, and then we have a client machine, which is mostly terminal based. Today, I'll mostly show you the terminal stuff. I know it's not as cool and clicky as the GUI, but I wanted to introduce you to the SAVI client because the later tutorials, the second one and the one in the afternoon about containers, you'll be doing quite a bit with the command line stuff. Is everyone here comfortable with command line, or have used command lines before? Who hasn't? Okay, because I was thinking of somehow pairing you guys together, if that would help. So basically, on your actual, the little strips that I handed out to you that I was ripping on the back when he was talking. I gave you a user and password, and so the first 3 columns, the first column has a username and password combination, the second is your tenant name, and the third is your network name. You'll use the network name later on in another, in the third tutorial at the end of the day. For now, you just need your username and password to log into the SAVI client machine. So the SAVI client machine URL can be seen right here, client1.savitestbed.ca. So if you can SSH into that, and I'll give you guys like a minute or 2 to figure out how to do that. Anyone not know how to do that, so I can come back to you? Oh, it should be. not user one. Ignore that user one up there. Just an example. So actually, let me go forward 2 slides. I think there's a picture. Yeah, for those who are using PuTTY right now, there's a, oh yeah, if you're using like Ubuntu or Mac, your terminal already has an SSH client, so you can just type this in directly. For those in Windows who are using PuTTY or any other type of SSH client, just type in client1.savitestbed.ca into the hosting field. Again, like, let me know if anyone has issues. Yeah. Yeah, because I use like Arial, sometimes the I's look like L's, capital I's, they look like L's. Right, so everything's all right. So I'll continue going by a little fast. So basically, accessing, you guys are all doing that right now. So once you're in, so those of you who managed to log in, if you haven't, let me know, I'll come help. Those of you who've managed to log in, you first have to set a number of environment variables first. So to set these environment variables, run the command source SAVI, your username, project, and region. So basically on the sheet that you see, your username is comsoc with a certain number. Where it says tenant name, like workshop-number, that's your project. And then for the region, for the first session, which is right now, everyone use core. And then for the password, it's the same password as the one you used to log in. And if you type the password and everything incorrectly, sorry, yeah, if you typed everything correctly, like it should say you're ready to use whatever. Like an example here, comsoc 12 is ready for workshop 12 on core. I'll walk around and just take a look. right now, so just for the SAVI basic, I'll just have you guys put up the single VM, and then we'll get into much more interesting stuff. So. Yeah, well. So, okay, after this, I suggest you to get together on one screen. Okay. Okay. So after this, so everyone good? After this, you have to set some default things. So whenever you create a virtual machine in the cloud, right? How do you access that machine? Traditionally, what's done? Anyone ever used AWS or Azure? No. Okay, 2 people in the back. Once. Okay. So most clouds out there, when you boot up a virtual machine, they secure. The only way you access it is mostly through SSH. But to secure it, you need to create like an SSH key pair. Anyone who's familiar with public key cryptography, that's basically what it is. So, and then to access, to actually secure the VM, most public clouds, including OpenStack, will also have extremely strict firewall rules. So to allow you to access it, you also should enable TCP port 22 to allow SSH access into your newly spawned machine. So we've kind of wrapped all that up into one simple command, SAVI add defaults. The key name, you're free to specify whatever key name you want. Use, say, like your name, for example. So if you type SAVI-add-defaults and then with a key name of your own, what this script will do, and also this script, it'll tell you what it's doing, and at each step in yellow, it'll show you what command under the hood it's actually running. So this way that if you come back later in the day or later tonight or when you go home, if you want to try it again, you can learn what commands it's actually doing under the hood. So yeah, so when you run this script, what it's doing is one, it'll create, if it hasn't already created, it'll create and upload a new key pair to the SAVI testbed, and then it'll also create a security group for you. Like I said, the security group is essentially just to tell the cloud to allow SSH and also allow, I believe, ICMP for pinging your VM. And then it'll add rules to the group. So if you run that, so how's everyone doing? All good? So if everyone's done that, the next scripts to run actually boots up the virtual machine itself. So again, we have a script for booting up a virtual machine. It requires 5 parameters. So one is the flavor, image, the key, the security group, and the name. I just realized this slide doesn't have an example. So, right, okay, so for the purposes of this workshop, okay, yeah. So for the purposes of this workshop, when you run the script, like I said, the 5 parameters, for the flavor, use n1.small. For the image, use Ubuntu-14-04. The U in Ubuntu should be capitalized. The third parameter, the key, should be the same key that you used in the previous script. For the security group, just use defaults. And then for the virtual machine name, pick your own name. I'll just do a quick walk around. Your own name. It doesn't have to be fancy. We'll probably just delete it later. Sorry? Oh, M1. Yeah, that's a 1. Yeah. Also yeah. So that's M1 up there. It's not an L or an I. I really chose a terrible one. So how many people see a VM moving up or see something there? So to refresh the status of that line, you can type, do I have it here? So yeah, so to refresh that, to list the existing VMs you have and to refresh the status of the VM, you can type nova list. Yeah. And again, like for anyone who's falling behind, all this is in that giant Google Doc that I sent you guys. So just look back there for the instructions. Yeah.
So the network name is the VM name or is that?
No. The network name will be used later on.
So what's the VM name?
The VM name is something that you come up with.
Oh, okay.
Yeah, whatever you want to name it. So I just noticed something right now. This is my fault. In the past, when we've run this, we usually bring our own wireless access point to give everyone direct access into our testbed. I didn't bring the access point this time. So when your virtual machine boots up, it gets an IP address that is only accessible within our network. So you can't directly ping it from your computer, but that's fine. If you open up another terminal, actually no, you're already in the client. You can access from the client 1 machine that you all SSH'd into. From there, you can access all the internal IP addresses of our testbed. So from there, you should be able to try and ping the IP address of the virtual machine that you just created. Yeah. So everyone's VM was properly booted up. Any questions? Yep. Oh wait, and now what was the key you used for? default username, I'll get to you. The default username is Ubuntu for the virtual machines. So Ubuntu at the IP address of the virtual machine. If you get prompted with this authenticity, whatever, just click yes, and then you'll be SSH. Yep. So from here, get the list of existing VMs. So the IP address is 10.12.121. So from here, you can't SSH from here because this is your computer. It doesn't have direct access into our testbed, but the client one machine is like a gateway into the SAVI testbed. So from here, you can SSH it. So you can try that right here. So if you type your logo right now, see on the right-hand side. So if you SSH'd, if you successfully SSH'd into your VM, you can track the Google.
Because I haven't had it never supposed to happen. But you know, because it's important enough, let's see. So when they show up, I just go into the room and show them. I'll let you know as soon as I find out. Thank you.
Okay. So yeah, so from within, so now you essentially have access directly into a virtual machine in quote unquote the cloud. And from there, you know, depending on your experimental or application needs, you can do whatever. You can install a web server, you can install a database, you can do any number of other experiments or applications that you can creatively think of. All these virtual machines should have access directly to the internet. I mean, you can try and ping Google really quickly, but for the purposes of time, so I just want to move on from this really quick SAVI basic. So if you're still logged into your VM, exit it right now, back to this SAVI client. So yeah, if you're in your VM and you haven't exited already, just type exit to get out of it so that you're back in the client one machine. So once you're in the client one machine, just you can delete your virtual machine to basically release the resources back into the pool by typing nova deletes with the name of the virtual machine. And you can verify that it was properly deleted again by typing nova list. So those of you who haven't done so, try and do it now. So again, like this is simply just a very hands-on. I know we didn't do anything with this virtual machine. This is just an introduction. The next session that we'll get into as soon as everyone deletes their virtual machine is multi-region orchestration. All good? Right, so, you know, I know this wasn't terribly exciting because all you did was boot up a VM and didn't do anything. The next session, like I said, much more interesting. So, before I move on to the next session, again, I mentioned this at the very beginning. There is also a web portal for those of you who prefer pointing and clicking with your mouse. It's located at portal.savitestbed.ca. I don't have time to go through that, but again, the instructions should be on the master handouts that you guys all opened. And there's also another session which we cut for time. You can do it on your own time at home. It's an exercise. It's using the SAVI testbed's monitoring and measurement tools. It's called, so essentially what it does is you can monitor statistics about your virtual machine's utilization. You can monitor the CPU utilization of your machine, you can monitor the network bandwidth of your machine, et cetera, et cetera. And what you can do is that you can also set alarms, right? So if you want to monitor your infrastructure and you want to know when the CPU utilization goes above, say, 80%, you can set an alarm to do so. And when the alarm triggers, you can also set different actions. The most common action is like email you just to alert you, say, oh, my resources are now this high. And you can, from this, you can even start imagining more complicated scenarios where once that threshold, that 80% threshold has been passed, that alarm can trigger, for example, a scaling action where you can scale out or scale up your infrastructure. But yeah, that's your own time. For now, I'll quickly move to the second session. So on the master handout list, basically the second session is here. If you go all the way up to the top, second session, layer 2 wide area network and service chaining. So yeah, so everyone cleaned up from the last thing we did? Okay, cool. So in this part, we'll basically teach you how to deploy like a very simple application across multiple regions. As was presented by Professor Leon Garcia, the SAVI testbed is comprised of multiple regions. And there are multiple tiers in these regions. We have the core tier, where the core data centers are very large, and they contain hundreds of virtual CPUs that can be used for virtual machines. We also have a second tier, which is closer to the end users, called the edge tier. So the edge tier essentially are clouds as well, but they're closer to the end users for if your application needs low latency requirements, for example. So what we're going to do now is we're going to deploy an application using an orchestration tool that deploys virtual machines in two different regions, the core tier and then one in the edge tier. And then you can see how we can leverage SDN capabilities to actually do some cool networking stuff with it. You'll see. So again, the online handout is here, which I believe you guys all have open. So a quick outline to this section. Before going into the application deployment, I'll talk really super briefly about heat templates. So those of you who've probably used Amazon, I believe they call it CloudFormation. So basically it's the same concept where you have a template file. Using that template file, you can describe what your application is. In the sense that you can describe, I want my application, quote unquote application, to be composed of 2 virtual machines. I want this virtual machine to be configured one way. I want the other virtual machine to be configured another way. So Amazon and OpenStack, they have their own technologies and they have their own languages for describing these applications in file format. So when you want to deploy your application, you can reuse the same file and just submit it to the cloud. It'll read and parse the file and deploy the application for you in one shot. So that's actually extremely useful for when you want to redo or rebuild your applications very fast without much manual work. So that's what heat templates are. Heat is the orchestration engine in OpenStack. And we'll talk really quickly about application flows. After that, we'll do a distributed WordPress application where the database of the the database of the WordPress website is in the core region, whereas the web server is in the edge region, closer to the end users. And then we'll talk about how to enable inter-region layer 2, so pure Ethernet connectivity. As Professor Leon Garcia said this morning, the SAVI testbed at the base level, we don't use IP. We control our network flows purely through Ethernet only. And then we'll do a little bit of dynamic service chaining. Those of you who were here yesterday, the guy talked about NFV super briefly. So just to quickly recap, NFV is a concept where you can take networking applications that were traditionally built in boxes, like firewalls, deep packet inspection things that came in expensive physical boxes, and implement the same features in software. And what you do is you simply deploy this software in a virtual machine in the cloud. So the question is, like, how do you get your traffic to go through these boxes, right? If you deploy a firewall, how do you get it to go through these boxes? Well, you can use SDN to help you with that. So you can, through an SDN controller, you can say all the traffic, all the HTTP port 80 traffic, I want it to go through this firewall before going out to the internet. So it's basically like you can dynamically change the routes in which your network traffic passes through. Any questions on that? Cool. So yeah, like really quick overview. So heap templates, as I mentioned, is OpenStack's orchestration engine. You can bundle a set of cloud resources related to a single application. And it allows you to deploy the application easily on different regions or different cloud infrastructures. In OpenStack terms, a single deployment of a heat template is called a quote-unquote stack. Not very creative. So these templates can be used to manage the entire life cycle of the application. You can update stacks. So if you deploy an application with one stack, you can later go on, update that template file, and then just update the application dynamically on the fly. So you can modify a running deployment. You can also use it to track the resources related to the single application and then delete them as well. So at a very high level, heap templates have three things. They have inputs, resources, and outputs. The inputs are basically variables, right? Which you can see later on. So any input variables you need to feed into the template, for example, what names do you want these virtual machines to be called? You can use a variable for that. Which regions do you want different things to be added in? And then there's also the resources, which is the set of cloud resources that encompasses this one application. And whenever I say cloud resources, I don't want you to be restricted into the thinking that these resources are simply virtual machines. These cloud resources can even be things like IP addresses, right? Or different virtual networks. These are all, we consider all these things to be a resource. And then you can also configure these resources as well. And then the outputs is just any useful information that the user may want to know. So for example, when you'll see later on when we deploy this application, it'll automatically get assigned a publicly accessible IP address. So you want to know what that IP address is, so you can output that. And that's just a simple example of a heat template. I'll skip this right now. So another quick concept to really cover. So Professor Leon Garcia mentioned how the SAVI testbed is the control and management layer is using something we built in-house called a software-defined infrastructure manager. We call it Janus. So what this software-defined infrastructure manager does is that it also exposes a number of APIs on top for people who want to build more complicated applications, right? So our Janus manager exposes a number of northbound APIs. A set of these APIs allows you to request custom network connectivity in the SAVI testbed, basically. So basically, they're SDN APIs. They allow you to install custom flow paths through our physical network itself. And again, like this is done without any tunneling technology. It's pure open flow. And the orchestration engine can leverage these capabilities to define custom networking policies and to create unique networking behaviors. And then we'll show two later on. So yeah, this is just the picture. You can have an orchestration platform up on top, calling the APIs on the Janus manager, which then installs the flows into the physical network. So connecting to CLI server, I believe you've already done this, so I'll skip this part. This should be updated. So in the working directory, let me update this really quickly. So you should have, in your home directory in the SAVI1 client machine, if you type ls just to see what's in there, you should see a directory called comsoc12 within comsoc17. Within comsoc17, there should be another directory called layer 2 chaining. So if you can all cd into that directory right now, you can simply type cd tilde / comsoc17 / that's an L, not a 1, L2 chaining, just to clarify. So I'll walk around really quickly. Everyone's in that directory? No. So if you're in that directory, type ls just to list what files are available in that directory. So in the directory, you should see three files with the extension YAML. It's pronounced YAML. So basically, these YAML scripts are the heat templates themselves. At your own time, on your own leisure, you can view these files just to see what these templates look like. You should also see 3 shell scripts, which I created just to simplify the deployment process for you, because you'll be typing a lot. Did you have a question? Sorry? Good? Okay. Right. And again, like all these templates and shell scripts, they're all on GitHub. I can, those of you who want to look at it later, I can give you a link. So now we're ready to deploy the distributed WordPress application. Any questions so far? Any problems? Let me know. Again, if you fall back, there's the handout. So as I described earlier, like we're going to do a multi-region deployment. We're going to deploy a database server in the core region of our testbed, and we're also going to deploy a web server in the edge region, closer to the end users. So this multi-region will contain a backend MySQL database in the core, a web server hosting WordPress in the edge, and the template also creates a firewall the template will also create another virtual machine that actually has firewall software installed in it. That'll be used later on. So this is just a very quick snippet of the template file that you'll be using to create the application. And so for those of you who are probably wondering, why do these templates need inputs? This is an example. So like as inputs, you can specify which regions you want these things to be deployed in. So let's go quickly to the deployment stage. Oops. So there should be a script called create_stack.sh. So it needs 2 parameters. One parameter is the key name. Use the same key name you created earlier, and the second is the edge name. So for the edge, I want you guys to use on the little strips I gave you guys, region 2. It should be assigned to you. It's one of the many edges that we have. So on the scripts for the edge name, just type in the name listed under region 2 of your strip. And it's case sensitive, so it has to be all caps. So let me know once you've done that. So basically this script will, it ensures that your public key has been uploaded to both regions. And it then calls a heat command to actually deploy these virtual machines across the different regions. And I just noticed one thing really quickly. Crap. Okay. Not this one. Yep.
What is the key name?
Yeah, do you remember earlier you ran SAVI at defaults and you created your own key name?
Okay.
Yep. command, and it's booting up. Yeah, yeah, yeah. Okay. So similar to Nova List, to refresh that status, you have to type heat stack list, right? And what you're waiting for is for the stack status to say create completes. You'll likely see, when you run this, you'll likely see 3 different stacks. How that actually works is because we're doing a multi-region deployment, we create one stack. That stack then creates another stack, another bundled application in each of the different regions, right? So it's like a hierarchical stack. So you're basically waiting for all 3 to say create complete, like here. So how many people see create complete? 1, 2. You have some errors? Okay. Oh yeah.
It's okay? Wow. Now we can.
Oh, did you log that? Did you exit that?
Yeah.
Oh, can you do that source? Do you remember the source SAVI? Yeah. Should be. If you can just search the document for source SAVI. Yeah. That's basically that. Oh, they log out. Yeah, yeah. It won't actually say WordPress. Depending on the stacking, I believe it'll just use your username. All right, so quick show of hands. How many people have all 3 that says complete, or 2? What about you 2 over there? 3?
So we have 2 creating progress and 1 2.
Which region are you in? I mean, which region were you assigned on your strip?
CT1.
CT1? CT should be okay. Yeah, wait a while and then let me know if it completes or not. For those of you who actually have all 3 that says complete, try running the stack output.sh script. What you'll get back is an IP address, and I just want you to copy and paste that into your web browser. So basically, as part of this stack, what it does is it also allocates a publicly accessible IP address, and then it associates this IP address with your web server, so that when you go to that IP address, it actually hits that web server. What?
Says there is no such white in the
Oh, sorry. Yeah, yeah.
What do we need to do about it?
Copy and paste it into your web browser. Yeah, just highlight it. If you highlight it, highlighting is copies. So if you can see WordPress, that's great. What I want you to do is just proceed and type in whatever random values you can think of. Just set up a sample WordPress really quickly. It doesn't need your real email. You can even put in a fake email. Was all 3 stack all complete?
Yeah.
No, it shows something
few more minutes and maybe configure it. If not, maybe follow along. So anyone else has issue seeing their magical WordPress? How many people can see the WordPress page by now and have gone ahead and set it up? You two? I know he's setting it up. What about you guys? No? Yeah, copy. Yeah, browser. It may take a few minutes for it to fully set up. You said your calls are
It's working on the web browser, but not on Mozilla. It's working on Chrome.
Oh, really?
For me, yes.
So this gentleman just reported something odd. Apparently it works in Chrome but not Mozilla Firefox. That's odd. I've never tested with anything other than Chrome, so that's my bad. Okay, so if everything's good, I'm gonna just go on and proceed. So basically after you set up your WordPress with some random inputs, you should see a sample WordPress blog. So now we want to demo actually two things. The first is, so this is a slight side tangent. The first is enabling layer 2 connectivity directly between your the web server and the database. So basically, as I mentioned earlier, this multi-region deployment, it has a database in one region and then the web server in a completely different region. So right now, their traffic by default, because they're in completely different networks, they have to go through routers, right? So how many people here know networks or basic networks? Do you know the time to live field? Yeah? So the time to live field, so whenever you do, for example, pings, they have or other protocols, they often have a time to live field. So what happens when you go through a router? It decreases by 1, right? Yes. By default right now, the way the SAVI network is set up is that within each region, they have their own router-free network, right? Within another region, they have their own router-free network. But to get from one region to another, we access it through a tertiary network called Orion. Orion is basically the academic and I believe governments as well. Provincial, okay, yeah. So Orion is the provincial, basically ISP for many of our public universities. And so basically, to travel from one region to another, it has to travel through at least 2 routers, right? So, but by default, what this means is that inter-region traffic has to pass through a layer 3 switching device, or sorry, a layer 3 routing. But sometimes for some applications, depending on if you're experimenting with maybe a novel internet protocol that's not traditional IP, you may want to have a direct layer 2 Ethernet-based connectivity between 2 different regions. So what this means is that there's no more need to go through IP routers, and this has many benefits. One is that you may see some lower latencies, and again, like I mentioned, if you're developing non-IP protocols, this is perfect. So SAVI has, to wrap this up, like I said earlier at the very beginning, we have APIs on our Janus SDI manager that allows you to install custom flows, custom SDN flows into our network. And this is essentially how we enable this direct layer 2 connectivity. But we don't have time to teach exactly how to use this. To simplify these advanced networking capabilities for the end users, we created a web portal. And under the hood, how this web portal is simply calling the APIs of our Janus SDI manager. So let's see. Right, so we basically replaced the routers with our own OpenFlow switches. So if you remember the past picture, there are routers here, IP-based routers, and now they're just OpenFlow switches, which we control. And all the forwarding is based purely on layer 2 max, so Ethernet max. Yeah, so the URL is not here. Okay, let me exit quickly. So I believe the URL should be in here. Next portal. Right. Okay. So I don't know if everyone can see that. We created a portal that basically simplifies all this for you. The link is ext-portal.savitestbed.ca. If you can open a browser to go there quickly. It's kind of small, so if anyone needs me to repeat it, let me know. And you can log into it using your, so the credentials are exactly the same as the username and password on your strips. So for example, for me, I'll use Comsub12. Yeah, ext-portal.savitestbed.ca. Here, I'll put it up on the slide actually. So yeah, at the bottom here, for those who had trouble seeing, ext-portal.savitestbed.ca. So everyone can see that, and you've logged in. So once you log in, on the left-hand side, you should see a tab that says L2 WAN or Layer 2 WAN, and it should look like something like this. And ignore that for now. That's just my resource, but you should see your resources if you choose the. If you choose your region and well, you only have one project, but what you can do now is, let me go forward. So, okay. I don't have exact pictures here. So everyone's logged in. So what I want you to do now is on the top right-hand side, it should say, it's cut off here, but it should say New WAN. So try clicking on New WAN. So when you click New WAN, you can enter whatever WAN name you want. It's up to you to specify a name. And then you click Add. So everyone's done that? Sorry, let me see. Oh, add, no, leave it empty. Yeah, sorry. So once you've created a new WAN, make sure it's selected here in this field here, this drop-down menu. And what you want to do is first go to switch. After it's selected, go to core. The core region here, it's the drop-down menu here in red. Go to core, and then find your database virtual machine, and then click on add. What that'll do is it'll add that virtual machine into your custom layer 2 LAN. So I'll walk around quickly. So yeah, click on core. So you see that's your database server, so just click add. Yep. Wait, that's your one, right? Can you add? Oh, God. Anyone else? Is anyone able to add to the line? Yeah, the web server. So if you're able to add so basically you want to add the database and the web server into the same WAN. So if you added what, the web server? Yeah. So then go to core and then add the database to the same WAN. Now it works? Okay. So everyone's done that. They've added the database server in core and then the web server in the edge region. Oh, yeah, okay, that works. Which region are you in?
I'm working.
So how many people have managed to do that? And so you added both. Cool. So now that you've added both, oh, it's right here. Now that you've added both, back in the terminal, there should be a third shell script called ping web serve to DB. Just execute that script. Basically what it'll do is it'll SSH into your web server and then just ping the database a given number of times. And I want you to check out what that TTL is. Just press tab. Yeah. Okay, that's good. Great. Yeah, give it some time. So I got one guy who reported 64. So those of you who aren't sure, the Linux implementation of ICMP defaults the basic time to live to 64. So basically, What this means is that it's now directly connected at layer 2. Like it's no longer going through IP-based routers that would normally decrement the TTL. It's all going through our OpenFlow switches that is directly doing the forwarding based on MAX alone. So everyone's able to see 64? Anyone has issues with that? So go back to go back quickly to that portal, right? If you're logged out, log in again, and I want you to delete that, remove that WAN. Yeah, there should be a remove WAN. It's red in the top right. And once you remove it, try running that ping server to database again and check out if it's now been decremented. Yeah. Yeah, so now you should see that after you remove it from the WAN, now the TTL should be 62, indicating that it's gone through 2 different routers. Yeah. Just remove the WAN and click OK. So you removed it, right? Yeah. So. Oh, okay. Okay. So you never saw the 64?
No, I just saw this.
Oh. Okay, but you see a difference. Okay. You're working with which? Yeah, maybe on your own time if you
Oh,
want.
sorry, I'm working.
Yeah, Victoria. Maybe on your own time you can try this one. I'm not exactly sure why. All right, so this is just a really quick sample of some of the more advanced networking capabilities that our testbed offers. Again, you can explore this on your own time. Everything is available on the handouts. And there may be some other applications as well on the extended portal. So right now, I want to demonstrate really quickly dynamic service chaining. So this goes back to what the guy was saying yesterday about NFV and the move towards software-based networking applications, where this software is deployed in a virtual machine. So what we want to do now is, we would like to protect our web server against an HTTP URL injection attack. We're not going to be doing any actual injection. So basically what this, you'll see, but what this does is every HTTP request that's made, it'll look at the actual URL, and if it finds a certain string, a short string that it deems as unsafe, it should just drop that packet. So basically, within the heat stack that you created earlier, remember I said there's actually a third virtual machine that's booted up. That's the firewall machine. And actually, if you were in the web portal, you probably saw that firewall. So our goal here is simply to chain all TCP traffic destined to the web server to go through that firewall. And this is essentially the power of OpenFlow in that with those 12 or 44, if you're using a newer version of OpenFlow, with those fields, you can specify which traffic to drop or reroute very explicitly. So TCP web traffic is TCP port 80, and then destined for the web server, so it knows exactly what the IP and MAC address of that web server is, right? So yeah, so again, the goal here is, right now, this is quote unquote vulnerable, and then after we do the service chaining, oh, there's some animation, cool. We should see it protected. So right now, before doing any chaining, I want you to quote unquote launch a mock attack. So you still have the IP of the WordPress that you have earlier in the browser. If not, just run the stack output script again. So go to you know, the HTTP:// the IP of your WordPress server. And then at the end here, I want you to add /?inject. That is our mock attack. And because right now, nothing's going through any firewall or anything, what we expect is that the page should just load normally. So it ignores those extra fields in the URL. So this should take you 30 seconds. Let me know if anyone has issues. $inject, yeah. So yeah, $inject, and it should load normally, right? Not good. Oh, did you set it up? Yeah, just put in random values and just finish setting up the accounts. So those of you who have put $inject, that's great. So basically right now, revisit the extended portal. Again, on the left-hand side, you should see another high-level networking application called chaining. So what I want you to do, click on chaining. And then once you're there, select your tenant from the drop-down menu. You should only see one, so that should be fine. And then afterwards, select the edge region that you've been assigned in that drop-down menu. Once you've done that, click on New Chain in the top right-hand corner, and in the pop-up, in the resulting pop-up dialog, you can just enter any name for the chain, and then just click Add. I'll do a quick walk around just to see how people are doing. Yeah, so it's only limited to the gateway of your network and anything else that you have. So what you can do is you can actually run this multiple times and start going up multiple hops. So if you've all created a chain, what you can do is you can start, what you should see is, so you should see 3 fields. You should see a head, a middle box, and a tail for the chain. For the head of the chain, insert the gateway. So everyone should see at least one free node called gateway. That gateway is essentially, well, it's the gateway to your private network. For the middle box, insert the firewall. And then for the tail, insert the web server. Just, yeah. Yeah, so when you, so for example, click gateway. Sorry, no, add. And then insert it as the head. Click on the firewall, or yeah, insert that as the middle box. And for the last one, insert it as the tail. So, oh, really quick. Once you've done that, if you haven't already, just click Setup Chain in the bottom right. And then you'll see some spinning circles that'll last like 20 seconds or so. And if everything's okay, if you try and refresh the page, actually Chrome may cache it. Just do a Shift F5. If you try and do that inject again, it should not load the page. Okay, so this guy is successfully blocked. That's very odd. Try creating a new chain. You click setup chain. Wait, hold on. Gateway. The middle box should be the firewall. Okay, so what I want you to do is click on remove chain. So yeah, for the middle box, make sure the middle box was the firewall. Yeah, make sure the middle box is the firewall, so I'll have it go through it. So after that, try again. Oh, do you? Oh, you should set it up first. Yeah. Yeah, and enter any random values. Set up the website. Enter a. So yeah, and then what you can try, if it's successfully blocked, just try removing the chain. Wait until it's removed. Try it again, just to show that everything is real. So once you've removed the chain and you've verified everything works again, we can start ending it. So removing the chain will not actually delete the virtual machines. So to clean up your stack, back in the client 1 terminal, I just want you to type heat stack -delete and then the name of your stack. I believe the name of your stack should have been automatic, should have been defaulted to your username, so it should be comsock something, right? So how's everyone? I'll walk around quickly just to see how everyone's doing. You're able to remove it? Oh, you did the blocking part and then you removed it and it works good? Oh, okay. What do I hear? Did you delete the gene? Is this still there? Okay. So you removed the gene, right? Okay, cool. So now you can proceed to delete the stack to free up back in the terminal. Delete the stack. So this will actually clean up all the virtual machines that you allocated in the multiple regions. So is there any questions so far? So I know some people had, I think 2 people are having issues. I'll take a look at it. Other than that, what about others? Anyone have any questions or any other comments? So gateway should be out. Firewall should be no box, but server should be out. And then again, just type heat stack dash list just to verify that all 3 stacks have been properly deleted. And if that's been verified, then you're done. No questions? Heat stack dash. Oh, are you deleting or is this?
I'm just trying to list the name.
So you can delete. Just if you, yeah, just type stack delete consoc 3. It should automatically delete all 3 of them. And like I said, everything's in the handout. So. Alright, so if there's no further questions from anyone, again, those of you who may be struggling, I can help you out, but if there's no other further questions, I believe we are 6 minutes overtime, so we can go for lunch.